Good morning and welcome to the Concept of Science. I am Rajesh and you are watching episode 1 of Conceptual Physics. My purpose is to help you in getting success in various competitive exams. If you like my classes, please do not forget to like the button and subscribe my channel. So today's topic is unit and dimension. There are so many things that I have heard that people have a lot of problems in physics, and especially the students, they are afraid of physics. Why? Because they do not have concept. They are weak on the concepts. So my purpose is to give you the concepts of the physics uh, um, that that will help you to understand how to approach a problem, how to solve the numericals, how to understand the physics well. Once you understand the physics well, trust me, this is going to be very, very interesting subject for everybody. And so we are going to start today with fundamentals and derived units because this topic is unit and dimension. So first we are going to discuss fundamental and derived units. What are the units? So you have in everyday life, we measure things around us in a certain way that we can count them in numbers. The fundamental thing about any unit is to count anything in number. So there are so many examples. Let me give you one unit name. Okay, the unit that we all know, like a dozen. What is dozen? Dozen is a unit. Now, if I tell you to count something in a dozen, how many numbers there will be in one dozen? If I ask you to give me one dozen of egg, how many eggs you are going to give me? You are going to give me 12 eggs, right? So what does it mean? It means dozen is a unit that contains certain number. Now, if I tell you why dozen is a unit, because this is one unit that contains 12 numbers. Now, if I ask you 2 dozen, what will be the number? This is going to be 12 multiplied by 2. Means 2 dozen means 12 multiplied by 2. This is 24. 3 dozen means 36. And so on. So to count things, we make some units, and in that unit, that chosen unit, we use certain numbers. Okay, so in everyday's life, we measure things around us in a certain way so that we can count them in numbers. The measurement involves comparison with a chosen standard or unit of similar kind. For example, measurement of physical quantity, it is uh, uh, it is essential that it is essential that we should express two things. Number one, the standard or unit in which the quantity is measured. Okay, and number two, the number of times that quantity contains the unit. Okay, so this is very clear here. Like, let me give you an example, as I was discussing before, that let's say a dozen is a standard or unit in which we count eggs. Okay, therefore we must know how many times an egg is contained or counted in 1 dozen. So you know the answer now, right? There are 12. The answer is 12 times. So we know now an unit is called dozen that contains a count of 12 of an egg or anything, right? It can be 12 bananas. 1 dozen banana means 12 banana. So fundamental physical quantities. What are the fundamental physical quantities? So by definition, the physical quantities which do not depend on any other physical quantity is known as fundamental physical quantity. So there are not too many physical quantities that are fundamental physical quantities. There are very few. Of them, three fundamental physical quantities, I will tell you now. This is mass, length, and time. So mass, length, and time, these physical quantities are called fundamental physical quantities because they do not depend on any other physical quantity. In order to, if you have to get the time, you don't need to know anything else. You just know the time. If you need to know the length, you don't need to know anything else, just need to know the length. And if you need to know the mass, you don't need to know anything else, you just need to know the mass. Why I'm saying you don't need to know? You will see this effect, the explanation when I'm going to explain you the derived physical quantity. Then you will understand that without knowing fundamental physical quantities, you cannot know the derived physical quantities. So what are the fundamental physical quantities? Fundamental physical quantities are those physical quantities that does not depend on any other physical quantity. Okay? Now, the units in which the fundamental physical quantities are getting measured are called fundamental units. So fundamental physical quantities are getting measured in fundamental units. I just told you that there are three fundamental physical quantities, that is mass, length, and time, right? So mass is measured in kilogram. So kilogram is fundamental unit, right? Length is measured in meter. So meter is fundamental unit. And time is measured in second. So second is fundamental unit. So fundamental physical quantities are measured in fundamental units. Is that clear? Good. Now the second thing, we have derived physical quantities. So what does it mean, derived physical quantities? Those physical quantities, they depend on fundamental quantities, fundamental physical quantities, or any other quantities in order to get determined. What does it mean? Let me get it more explanation. The physical quantities that depend upon fundamental physical quantities. What was the fundamental physical quantities? Mass, length, and time, right? So those physical quantities that will contain mass, length, and time, or something else, they would be called derived physical quantities. Why? Because if something contains mass and length and you do not have the mass, if you do not have the length, you cannot get that physical quantity determined. So, and their units, the units of derived physical quantities will be derived units. Now let's discuss about derived units. I just explained derived physical quantities, and can you give me some example which are derived physical quantities? Yes, there are so many physical quantities, they are derived. Few of them I will tell you now. Just like let's talk about velocity. What is velocity? So by definition, velocity is displacement per unit time. So if something is moving and displacement is taking place, in 1 second, what was the amount of displacement? This is called, if we amount of displacement, if we divide by the time taken, it is going to give me the amount of velocity. So in order to know the velocity, I need to know the displacement first. And when I know the displacement, I need to know the time in which that displacement was made. So now you see that without knowing these two factors, without knowing the time, without knowing the displacement, I would not be able to find the velocity. That's why I said before, velocity is a derived physical quantity that depends on fundamental physical quantities. And what are the fundamental physical quantities here? Displacement and time. Displacement is measured in length and time is measured in second, right? So now it is clear why velocity is a derived physical quantity. This is the question that I'm going to ask you, and if you can make it note of this question, why velocity is derived physical quantity, and why the unit of velocity is derived unit. So now you can answer this question, right? So let's move to the next thing. Now, similarly, how we determine the velocity? That velocity is a derived physical quantity. The unit of velocity. What is the unit of velocity, by the way? We discuss displacement upon time. Displacement divided by time is the velocity. Velocity. Displacement, unit of the displacement is meter. And the unit of time is second. So meter per second is going to be unit of the velocity. Right? Okay. So now here is some more thing for you. After knowing this, derived units, fundamental units, you learn about the fundamental physical quantity, derived physical quantity. I'm going to give you some more derived physical quantities. If you want to make a note, write down those physical quantities. These are the surface tension. Number 1, surface tension. Number 2, acceleration. Number 3, work. Number 4, moment of inertia. And number 5, force. So these 5 derived physical quantities I gave you now, and I want you to find their units. What are their units? Okay. So there is only one hint that I will give you, that first just try to find out their units. So you will see the problems there. You don't know the units and you don't know how to find them, right? This is going to be the problem. So why you are unable to find the units? This is the question. Why? Because you do not know the definition. And you don't know how to measure them. In the whole physics, the first thing you have to know is the definition of that physical quantity. And number 2, you have to know how to measure them. Okay? So, your takeaway is surface tension, acceleration, work, moment of inertia, and force. Okay? You have to define them, then you have to find their units. Okay? And this is the first thing here that you're gonna do. And in detail classes, I'm going to explain this everything step by step. So probably if you would like to join my detail classes, just let me know in the comment below. Okay? And let's move on. So I would like to discuss now the systems of unit. Okay? Systems. What do I mean by saying system? System means there are from the long time, from the historical time, there are 3 systems in practice. Systems in which we deal with the units. Okay. One is the CGS system. This is called centimeter gram second system. What does it mean, centimeter gram? Because as I discussed before, there are 3 fundamental physical quantity: mass, length, and time. So in CGS system, mass is measured in gram. Length is measured in centimeter. And time is measured in second. So unit of length in CGS is centimeter, unit of mass is gram, and unit of time is second. Another system is FPS system. FPS, foot pound second system. In this system, the unit of length is foot, unit of mass is pound, and unit of time is second. So in Britain, in Britain and so many countries, they follow the CGS system, centimeter, gram, second, and in United States, we follow foot, pound, second system. Okay, because they're the things are still, you go in the market and grocery and you buy the things by the pound, right? Measuring by the pound, how much, like a 2 pound or 3 pound or something. One is MKS system. MKS system in which the length, the unit of the length is meter, the unit of mass is kilogram, and the unit of time is second, right? Now, there are some interesting facts that I'm going to discuss with you. Probably it will help you in so many competitive exam. This is just to know the interesting things about this. Number one, what is 1 meter? 1 meter is the distance that contains 1650,076. It means 1650763.73 wavelengths of orange red light of krypton 86. Right? Now this is a funny, like you are thinking like what is this all about? Just this is the interesting fact. Okay. Number two, 1 kilogram is the mass of 5.0188 into 10 power 25 atoms of carbon 12. It means in 1 kilogram carbon 12 atom, how many carbon 12 atom will be there? 5.0188 multiplied by 10 to the power 25. This is a huge amount of carbon 12 atoms. We will discuss all these things. What is carbon 12 atom and all those, what are the wavelengths, what does it means? We will discuss it in different classes, probably in chemistry or in physical chemistry. And number three is 1 second is the time in which cesium atom vibrates this is a lot. This is a very big, like if you want to write down the number, 9192631,770 times. How many numbers are there? 10 numbers, right? So it is like a billions. 90, I think it is 9192631,770 times in an atomic clock. When cesium atom vibrates that many times, then it happens 1 second. So okay, let's go to a little bit outside these interesting facts now. So number 4 system. So we have 3 systems before. We discussed CGS, FPS, and MKS, and now we are going to discuss the number 4, that is the final. This is called SI system of units. This is called Sistema International, and in this system there are 7 fundamental physical quantities. Remember, CGS, FPS, MKS, all these 3 had 3 fundamental physical quantities. In Sistema International, in SI units, we have 7 fundamental physical quantities. Okay, and what are they? Number 1 is mass. This is fundamental physical quantity. This is the we measure them in kilogram. The symbol is kg, capital K, small g. Number 2 is the length. Length is the physical quantity. We measure them in meter, and the symbol is capital M. The third is time. Time is measured in second, the symbol is a small s. Fourth is the temperature. Temperature is measured in Kelvin and the symbol is capital K. The fifth one is luminous intensity. We measure luminous intensity in candela, and the symbol is capital C, small d. Number 6 is electric current, and electric current is measured in ampere. The symbol is capital A. And the seventh one is amount of substance, that is measured in mole, and the symbol is a small letters MOL dot. So these are the 7 fundamental physical quantities that is taken into the consideration in SI system, not in MKS, not in FPS, not in CGS, but in SI system there are 7 fundamental physical quantities, there are 7 fundamental units, and physical quantities are mass, length, time, temperature, luminous intensity, electric current, and amount of substance, and units are kilogram, meter, second, Kelvin, candela, ampere, and mole respectively. So this is the Systema International, and after that, after this SI system, in the SI system we have 2 supplementary units. 2 supplementary units, they are called physical angle, the units are radian, solid angle, the units are steradian. So there are 2 supplementary fundamental physical quantity, plane angle and solid angle. Their units, supplementary SI units, are radian and steradian respectively. Okay, so what are the characteristic of physical unit or standard? What kind of thing we will call physical unit or a standard? There are characteristics of that. So there are 4 indispensable characteristics of a physical standard. Okay, 4 indispensable characteristic of a physical standard. Number 1, they are invariable. Number 2, they are indestructible. Number 3, they are accessible. And number 4, they are reproducible. So if these 4 characteristics are not there, we cannot call anything as a unit or a standard. Okay, one more time. They are invariable. Number 2, they are indestructible. Number 3, they are accessible. And number 4, they are reproducible. Okay, so in other words, if a standard does not have any of the 4 characteristics as mentioned, now it is not qualified to be considered as a standard or unit of a physical quantity. Okay, now let's I will like to discuss some abbreviations for multiples and submultiples. This is why it is needed. We will discuss in a different class, but first of all, in this class I would like to give you some example like symbols and prefix and multiplier. So let's talk about prefixes and multiplier. Prefix tera, T-E-R-A, tera. Multiplier is 10 to the power 12. Giga, 10 to the power 9. Mega, 10 to the power 6. Kilo, 10 to the power 3. Hecto, 10 to the power 2. Deca, 10 to the power 1. Deci, 10 to the power minus 1. Centi, 10 to the power minus 2. Milli, 10 to the power minus 3. Micro, 10 to the power minus 6. Nano, 10 to the power minus 9. And pico, 10 to the power minus 12. Why it is important to remember that? Because you have to make it a note. You just go little bit you slide my video a little bit before. You have all these powers and prefixes. So you make a note of that. Why am I'm saying you to do that? Because in if I ask you which of the following is the smallest, which of the following is the smallest among other units of measurement, I give you four options: decimeter, nanometer, picometer, micrometer. You cannot say, because you don't know what is deci, what is nano, what is pico, what is micro, right? So in physics or in chemistry or in biology, we talk about very small length. We talk about nanometer, we talk about micrometer, we talk about decimeter, and you have to know what does it means. So this is why I said I gave you the prefixes, I gave you the powers. Now by the power, you know that if this is like a 10 to the power 6, it is greater than 10 to the power 2, 10 to the power 2 is greater than 10 to the power 1, and 10 to the power 1 is greater than 10 to the power minus 1. So now if you know all the sequence, you of course know which unit is going to be the smallest one. The second question I am going to ask you, which of the following is the largest among units of measurement? And the option is picometer, centimeter, micrometer, decimeter. Okay? And which of the following is the smallest unit of measurement? This is terabyte, gigabyte, picobyte, nanobyte. You have to give me the answer. Which of the following is the greatest unit of measurement? Terabyte, gigabyte, picobyte, nanobyte. You tell me. Okay? So to understand all of these kind of things, you need to be into the practice. You have to get to that measurement table that I just discussed with you. You make a note, go back in my video, make a note of that. Then you will be able to go through these questions what I ask you. Okay. Now this was the units that we studied about physical quantities and their units. Now in this chapter, because the chapter name was this video, the episode name was units and dimension, we are going to discuss about the dimension. So what are the dimensions? You understood what are the units. What is the unit of velocity? Meter per second, right? Now the dimensions. Dimensions are the powers to which fundamental units of mass, length, time must be raised to represent the derived units. Confusion, right? Let me give you an example. Let me make it very simple. So, give me one moment. Okay. So, suppose this way. For example, velocity is equal to displacement upon time, right? So, in other words, if we put, if we just write L at the place where is the displacement, because displacement is measured in fundamental physical quantity. Displacement is a fundamental physical quantity, that is length, right? So we write L by T. T is the fundamental physical quantity, that is time. So meter per second means length by time. Is that correct? So if length by time I write there, and what if you write them in the linear, like it is going to be L length T minus 1, right? LT minus 1. So what is minus 1? This is the power. This is the power. This is the power through which the time is raised in the derived unit. So this is what I'm saying. The powers to which the fundamental units of mass, length, and time are raised to represent the derived unit. This is called dimension. So for example, velocity is equal to displacement upon time it means L upon T, it means LT minus 1. Make sense? Yes. So LT minus 1 is the dimension of velocity. It means the dimension of the unit of velocity are 1 in length and minus 1 in time. Okay, its dimension in mass is 0, because in velocity you do not need mass to determine. You do not need mass to determine the velocity, right? You need only displacement, that is length, and time, that is second. You need only these two. So velocity means, what is the dimension of velocity? Dimension of velocity, length raised by power 1 and time raised by power minus 1. And that, what does it mean? It means L by T, L divided by T. Is that okay? Yes. So now, in other words, dimensions of velocity can be written as m raised by power 0, L raised by power 1, and T raised by power minus 1. MLT minus 1. This is going to be dimension of velocity. Now, what is the meaning of dimensional formula? Dimensional formula is an expression showing how and which of the fundamental units enter into the units of a physical quantity. Let me explain this thing to you. Let us consider a physical quantity, that is work, right? When we get the dimensional formula of work, we will be able to see which fundamental unit enters into the unit of work. You are getting what I'm saying? Like, work is a derived quantity. So what does it mean? Work is a derived quantity. It means it is depending on other fundamental physical quantities. Now, from those fundamental physical quantities, every fundamental physical quantity would have their unit. But when we derive the unit of work, some of the unit will be cancelled. They will cancel each other. How? Let me explain it to you. So we need to know the definition of work, as I was explaining before. What is the definition of work? The definition of work is when the force is applied to an object, and displacement takes place. Force is applied to an object and displacement takes place, then the work is said to be done. Very simple. You apply force on an object and you create a displacement from this place to this place. Force is applied on an object and displacement takes place, then work is said to be done. In other words, how do we measure the work? Work is measured by the force multiplied by the displacement. Force multiplied by the displacement. If force is suppose 1 and displacement is something, force is suppose anything and displacement is anything, you just multiplied both the things and then you know that this is the work done. Again, the definition of work is when force is applied on any object and displacement takes place, then work is said to be done. Is that clear? Now, how do we measure work? We measure work by multiplying force to the displacement. Force and displacement multiplied to give the magnitude of work. So we were what we were trying to obtain. We were trying to obtain the dimensional formula for work. Okay, we give the definition of work. So what is the dimensional formula for work? The dimensional formula for force is mlt minus 2. m1, m raised by power 1, l raised by power 1, and t is raised by minus 2. Okay, so this is mlt minus 2 is the dimensional formula for force. And what is the displacement? Displacement is the length. So m was mlt minus 2 means m was raised by power 1, l was raised by power 1, and t was raised by minus 2. Now we are multiplying one more displacement there, that is l. So it is going to be m power 1, l power 1 multiplied by l power 1 multiplied by t minus 2. So this is going to be the dimensional formula for the work, force into displacement. So the new equation is going to be m power 1, l and l, there was 2l, so m power 1, l power 2, t minus 2, ml2 t minus 2. This is going to be the dimensional formula for work. Okay, and we will have physical quantity and their dimensional formula. So I can tell you some dimensional formula here, and if you want to make a note, you can make a note. Okay, and that will be you have to find out. Let me give you some task. You have to find out the dimensional formula for acceleration. Make a note, please. Acceleration, momentum, force, work, power, pressure, stress, strain, coefficient of elasticity, torque, angular velocity, moment of inertia, angular momentum, latent heat, and thermal resistance. Try to find out the dimensional formula, dimensional equation, whatever you want to say, for all these quantities. If you want to learn how to do all of these things, please do not forget to write me in my comment section. Probably you will need to join my detailed classes. Okay, so thank you very much for listening to me today, and this was Unit and Dimension, episode 1, Unit and Dimension for Conceptual Physics. We will be discussing more about concepts of physics in forthcoming classes. If you like my lectures, please do not forget to like this video, and please do not forget to subscribe my channel so that you can be updated all the time, and whenever you want you can listen my lectures. If you have any doubt, just close your eyes, put your earphones, and just listen it. It is going to clear your concept. Thank you very much. Have a blessed day, and I wish you all the best. Thank you.